Hi, for our next installment of the HiPro Factory Side Chat, we have Kurt Martin joining us again. Thanks for joining us, Kurt. We're going to talk about filter sizing and selection this time. This is something that you do often. Is
Yeah.
it? What are some of the things that you like to or want to impress on the customer that you need as far as parameters whenever you receive information so that you can properly size a filter housing for their use?
Yeah. So when we're sizing filter housings, there's information we need to have in order to do it properly. If a customer sends a request in, what I'm going to ask them for is we need to know the fluid type, the name and grade of the fluid, the fluid temperature at cold start and operating temperature, the maximum system pressure at which the housing will be exposed to, the required micron rating that they're looking to add, then also the flow rate of the system that the housing will be used in.
So let's center on pressure initially, because you and I both notice that this is a problem that we see often. System pressure versus collapse pressure of the filter element. So, do you see a confusion with the customers often on those two?
Yeah, we do see that from time to time. So the system pressure, basically, you're looking at the upstream pressure, um, upstream of the housing. What collapse pressure or the differential pressure of the element, what that's measuring is the upstream pressure minus the downstream pressure, and each element's going to have a collapse rating. So let's say 250 psi D, the D standing for differential pressure. So what that is saying is anything below 250 PSID, so you take your upstream pressure minus your downstream pressure, the element's good, it's not going to collapse. Anything above 250 PSID, you run the chance of collapsing the element. So you could have a system running at 1,000 PSI on the upstream side, although that value is higher than your collapse rating. As long as you don't exceed 250 PSID, the upstream pressure minus the downstream pressure, you should be good to go.
So, in a system that's 1,000 psi or higher, 2,000, 3,000, 5, 6,000 psi, we can still use a standard collapse filter element if there's another component in the housing.
Yeah, the bypass valve. So that's there as a safety feature. So that way, once the element reaches the bypass valve setting, the bypass valve will open, relieve the pressure. It will help reduce the risk of the elements collapsing. It doesn't always prevent it depending on the scenario, but it greatly reduces the risk. And with high collapse elements, you're going to have thicker center tubes. The pleat packs are assembled a little bit differently on the support mesh that's used. And those are typically rated for 3,000 PSID, where the low collapse elements are typically rated for 500 PSID and less.
And with a high collapse filter element, we are going to be using a blocked bypass and no bypass valve in the system.
Correct.
One of the things I like to mention to the customer is if there's an error made where you're mixing those, one of them is not catastrophic, the other one is. So if we accidentally put a high collapse filter element in a housing that has a bypass valve, the negative is just spending too much money. On the flip side, what happens if we accidentally put a standard collapse filter element in a housing that has no bypass valve?
Most likely the element's going to come out looking like a soda bottle that someone stepped on. it will it will crush, collapse the ID of the element. You basically won't be able to see through it. The center tube will be crushed, and then obviously when that happens, that could lead to other problems, such as pieces of the pleat pack and whatnot breaking off, going downstream of the element. Obviously, when the element crushes, it's going to shed a lot of particles downstream. So that's a mistake you definitely don't want to make. It's putting a low collapse element in a situation where there is no bypass valve.
What we see with that is it's easy to do because dimensionally they're the same size. And what we see the reason is no fault of their own, but somebody looks at the price difference and it's a big difference. And they say, well, it's the same size, it fits, I can save some money, maybe a third the price of a a high collapse filter element, and then here we are. So I assume that's one thing that you definitely want to vet out if there's an existing housing and they want to confirm the filter element in that housing.
Yeah, for sure. A lot of customers think that they could just keep an eye on the DP gauge and say, well, I'll change it when it gets to X PSID and then it won't collapse. But we all know that that doesn't always work out. Maintenance schedules and whatever. That's not a good tactic to take.
So you mentioned that it's difficult to watch that, and we definitely don't want to put a standard collapse in a housing with no bypass valve. Tapping into your lab knowledge and experience, when do you see that filter element start to resemble the end of the hockey puck as far as differential pressure rise?
Typically about a third of the way through the element's life. That's when you really start to see the differential pressure really increase. So for an example, if you get an element and we're terminal DP 60 PSID, around 20 PSID, that's when you start to see that DP curve really start to ramp up, increase really rapidly. Within that first 20 PSID of the element's life, though, however, that's where you get probably 75% of your dirt holding capacity, because the last part of that of the element's life there is so short and so fast. The DP rises so quickly. You really don't get a whole lot of dirt holding capacity after that, and the like you mentioned, the DP climbs so fast after that point. If you're not basically standing there watching it, it could load within hours or days. So it's something you don't want to gamble and say, well, I'll keep an eye on DP and change it before the element collapses, because it happens very quickly.
One of the analogies I like to use as far as when people ask me, well, what do I need to use if I'm going to put a new filter housing in a system? Do I use a standard collapse with a bypass, or do I use a high collapse with no bypass? I like to ask them one question. Is the component downstream of that filter housing that you're about to install going to sustain damage that needs to be repaired quicker if you starve it of oil or if you provide dirty oil? And what I mean by that is, let's pick on a gearbox versus a high-end control valve. The gearbox itself can handle a lot of dirty oil, so we definitely don't want to starve it of oil. Versus if you do starve it of oil, it's going to start sustaining damage. Whereas a control valve, you give it any kind of dirt, like a servo control valve downstream, that's going to sustain damage quicker. That's one of the analogies I like to use, just to kind of help them realize which direction we need to go. So I just wanted to throw that out just to think about. Okay, so next thing I want to ask about is, you're doing filter sizing and you have all these parameters that you ask your customer about. A lot of people like to just center on differential pressure. If your differential pressure is good, you're good to go. That's not always the case, is it?
That's correct. We don't see it often, but we do see it from time to time in situations where you get a really high flow rate and a very low viscosity fluid, such as diesel. One thing you also need to keep an eye on is the velocity of the fluid traveling through the housing and the element. We like to size the housings so that the velocities less than 15 feet per second. Over that, you could, although the DP is fine, the velocity of the fluid going through the element could damage the pleat pack, bend up the pleats, and cause some damage. So that's also something you want to keep an eye on in those high flow situations with low flow or low vis fluids.
Yeah, that's good information. That's good information. So whenever you are asked to size a filter cart, what are some of the things that you ask whenever sizing the filter cart properly for their application?
So for filter carts, obviously you're wanting to, the information I ask for is very similar to if I'm just sizing a housing. Fluid type, temperatures, the flow rate that they're looking for, the micron ratings. But then I also want to know, on a filter cart, it's going to be used as a kidney loop. So typically in a kidney loop situation, you're putting a kidney loop on a system because it has dirt issues. The other elements aren't able to keep up. So I also like to ask for, what's the current ISO code of the system? A lot of times we will see situations where the ISO codes are really high, and that will also help us decide what type of kidney loop or filter cart, filter skid we want to put on the application. For really high fluids, ISO codes, we will sometimes offer larger dirt holding capacity elements versus smaller elements to reduce the downtime and changing elements, higher dirt holding capacity. So those are some of the things we look for when sizing carts, skids, panels, that type of stuff.
That's really good information. And one other aspect I'd like to add to that is higher flow rate is not always better. And let's say we'll pick on a tank that's 500 gallons or a tote that's 330 gallons and pick on two flow rates, a 5 gallon per minute or a 10 gallon per minute. A lot of people would say, oh, let's just go 10 gallon per minute. Well, it'll work. But if you have time and the ingression rate is not really high for the system, the 5 gallon per minute for the same size filters used on the cart, you're going to be able to pack in a lot more dirt in that filter element. Do you see that often where people will challenge that and say, well, I want a little higher flow rate, but they really don't need it?
Yeah, we'll see that from time to time. Like you mentioned, in higher flow rate situations, you'll see that affects the way the element loads with dirt. Obviously, the lower flow, the dirt can penetrate the media deeper, and it allows the particles to really fill in all those little voids and holes within the pleat pack. Where with the higher vis, you get more of a face loading. The velocity of the particle traveling into the element is at a higher rate, and it just kind of hits the face of the element and sticks there. So you really don't get the penetration into the media that you do with the lower flow rates. And then also something to keep in mind on like low volumes, and they're wanting to filter it quickly with a high flow rate kidney loop system, is sometimes you cause aeration in the fluid because there's just not enough dwell time. So that's another thing you want to keep in mind.
Yeah, that's really good information. So basically what we're trying to say here is filter sizing and selection is not an exact science. We look at each application individually, and then we help them determine what's best for them for their situation. As far as turns a day, let's say a customer asks you to size a new FSL skid, some type of fixed skid on the system. Turns a day, I typically would say a minimum of 8 to maybe double that if you're in a very difficult situation. What are some of the things you like to ask them when it comes to environmental conditions to help you determine the flow rate?
Yeah, so you want to look at the how dirty the system is to begin with. That will help us determine flow rates, the size of the elements. But then you also want to look at the environment that the application is in. Is it outside in a, I don't know, say the desert where there's a lot of sand, versus it's inside in a ultra clean room? So you got to look at those conditions, factor in ingress rates, and then size the unit properly. Obviously, we'd want to size the dirty environments a little larger, so that way we get higher dirt holding capacities. We could keep up with the ingress rate, and not only keep up with it, but get ahead of it, versus a system that's in a really clean environment.
That's good information. I think that's really critical because, let's talk about, just like you said, inside a building, a 500 gallon reservoir, a hydraulic power unit versus outside in a dusty environment. We are going to recommend a different flow rate for that fixed skid or that filter cart, and then that will dictate the filter housing size as well, because we want to make sure that we can keep up with the ingression and the generation of particles. Okay, so one of the things that I like to mention to a customer, and I know you get this often, is if they ask, do I need to step down my filtration efficiency, or should I go with just the really tight media right off the bat? What are questions that you ask them?
First thing I always ask is, what's your time frame? So if this is an application that needs to be cleaned up really quickly in like hours or a day or two, obviously you want to start with the tighter filter, but they need to be prepared that they would most likely use quite a few filters quickly, depending on the cleanliness of the system. If it's a really dirty application and they're trying to get it down to to a target ISO code really fast. That's a situation where you had to change filters quickly. A customer, just an example, we had a customer that we couldn't even run 25 milliliters of fluid through a test patch before blinding the test patch off. So this customer had time. The fluid was already in nasty shape. They just wanted to save the fluid at this point. They didn't want to scrap it. So what we did was we started with a 40 micron element, and that 40 micron element expired in a couple days. After that 40 micron, we then stepped it down to a 25 micron. That 25 micron element then lasted a couple weeks. Then we just kept working our way down to eventually they got down to like a 12 micron or 6 micron element, and that's where they were happy with the cleanliness of the fluid. So depends on the situation, how quickly you want or need to get the fluid cleaned up. If you need to do it fast, go with the tighter media right away, but be prepared depending on how dirty the fluid is that you may have to change elements quickly. If you got some time, it's always good to obviously work your way down. You won't burn through elements as quickly, and it's a good way to clean the system up.
Yeah, that's great. That's great. That's great information. Okay, well, that wraps it up as far as filter sizing and selection for the Hypro Factory Side Chat. Thank you, Kurt. Really appreciate your time.
Thank you.